This tutorial movie is about how to set up inflow control devices in thermal Wellbore simulator. If you go to data preparation, you open up a file. This is a steam injection pipe configuration, and if I look at the pipe configuration, we have three pipes: a casing pipe, a short pipe, and a long pipe. And I will display the pipe schematic. Long pipe, and steam is injected in both the long and short pipes. And the intent here is to inject about 200 millicubic cubes of steam down this long tubing, and have some fraction, say half of the fluid, escape through an ICD placed somewhere along this long tubing, so that the flow will go out through the ICD and also go out through the end of the pipe, and we would have a more balanced flow rate profile into the formation. So look at the long tubing string, and this long tubing string, the cementation is set up such that cement 93 is that particular cement has a certain perforation, and it's set to 0.15, so it's a reduction of the flow through this cement, and that is ICD set number here 1. So our intent currently is to run this program Twbs with this perforation fraction and see what the flow rate is in the distribution between the ICD and the flow at the toe of the tubing. We want to adjust this perforation fraction until we get the required fraction of flow through the ICD at section 93. So given 0.15, when we run this 0.15, I'll assume that I've run already, and if you look at the results of that run and open the particular case, the results of the run indicate that for the long tubing string, about 145 millicubic of steam is sent across the ICD. ICD is marked in green, 793. About 145 millicubic of steam escapes from this ICD out into the liner, and 90 millicubic of steam go to the end, to the toe of that long tubing string. So we want to make it about 118 millicubic of steam to go out instead of 145. So we can try to adjust the perforation fraction. So if I go back and close this and go back to the data preparation, I would open up that same file and make another case where I would change the long tubing perforation to say 0.07, for example, and then save that as a new file. Says there's ICD2, but that, and save it, and then we will try to run the test ICD2 and start the run, and then we want to see what the fraction of flow is. So if I open up the results of test ICD2 and look at the pressure and rates, you can see that the bypass rate in this case is almost bang on. It's about exactly the same amount of fluid goes through the ICD at 93, and the rest of it goes through to the top. So it's evenly split between this exit point and that exit point. So now, given that that good run, we want to size the ICD. We want to say how many holes do we need, or what diameter do we need to be able to allow this much fluid to go from the current pressure conditions into the annulus. So if I go and look at the ICD choke sizing program, in this program, if I get ICD values from Twbs run, I go test ICD2, and there was only one data preparation. If you remember, if I open up that file, in the long tubing string, I specified in section 93 ICD number 1. So this ICD1 refers to this number here, ICD1. So I click on that. Now the required water rate, these are choke conditions, they're not surface conditions, these are choke conditions. And for those choke conditions, now we want to calculate that choke diameter and number of chokes that will give us the target rate that we have obtained just now. So this is the target rate already in reservoir conditions at choke conditions, reservoir choke conditions. And let's say if I put in a upstream diameter, pretty large upstream diameter, and a required choke diameter of say 10 millimeters with a choke discharge coefficient of 0.85, and we can calculate the choke rates. So the choke rates indicate that we would need at least 17 holes of that particular diameter to allow this much fluid to bypass through the ICD that's placed at section 93. Okay, so that is number of holes. So we can verify it by running through the TWBS with a different way of doing this. In the newer version of TWBS, version 4 onwards, we can now specify, instead of the perforation fraction, we can now exactly specify the device table number with a negative in front of it as a flag. So the negative is a flag, so just put in -1 as a flag, -1, device ICD number, we can make this as 0. So for device number 1, if I specify the ICD using the ICD specification form, and I put in number of holes, which is in this case 17, and choke diameter of 10, and the diameter before the choke is 100, choke discharge coefficient is 0.85, and gas specific ratio could be 1.135, and I'm not using venturi, I'm not using a tapered bore, I'm using a straight bore, and this coefficient is normally 1, 1, and 1. And if I close that and then I save this data file as test ICD specified, save it. If I close that form and I run this again, and I go test ICD specified, and I start that run. So in this second way of doing ICD, I just simply specify the ICD device number, and I put in the number of holes and the choke diameter, and it will compute for me exactly what the bypass will be for the given size of the ICD. So I look at the results. If I open up that case I just ran, And you can see I bypass 117 meter cubes, so it's almost the same as the previous run, where I did not use the fixed ICD, and I had to prorate the perforation fraction to get the required flow of fluid through the ICD. So there are two ways of doing ICDs in Twbs. The first way is to set up the data such that we specify in the pipe data where the ICD is, we specify that fraction and this ICD number, and then we go through adjusting this perforation fraction until we get a target rate Q that comes across the ICD, which is what we want to balance that rate out. Once we got the rate out, we go through the choke ICD sizing calculation, and then we calculate what the number of holes necessary will be to size the choke. That's one way. The second way is to go in directly into Twbs, and instead of specifying the ICD number here, we will specify the ICD number here with a minus sign in front of it, minus say 1, and go in and specify the ICD choke diameter and number of holes, and the program then will simply run this and give us the different number of different rates. So in this case here, if I went through and took that case, and if I chose an IC specification instead of 17, I chose it to be say 25 holes. If I save that and I save this as ICD 25 holes, then I will say ICD say 25 and save it and then run it. Then I would get a different answer, but this will be a direct calculation of the ICD. And for that ICD, so instead of getting 117, let me see what I get here. I would get I'll get 94. So I would have more bypass using more holes. By using 25 holes instead of 17 holes, I'm able to get more fluid across here. And so this is a direct calculation of the ICD rate. Thank you for your attention.